Hey guys, Mr. D back again. A little more remote learning here. We're going to continue our weather unit today with a look at weather fronts, and we're going to start to piece together the skills necessary to maybe watch a weather forecast on the news a little bit differently moving forward. We're going to start to gain an understanding of what some of these symbols mean and some of the terminology that weathermen are constantly using as they tell you what's going to happen with the weather in the upcoming days. So let's jump right in here. Hopefully you've got your note sheet open in Notability. You uploaded that from Google Classroom, and you can stop this video as you go and fill in your notes with me. And again, super useful on CK12 assignments as well as upcoming assessments. So make sure you're doing those notes, saving them to Notability. Super useful tool. And let's jump right in. So we're talking about weather fronts today, and we hear that word front all the time. If you've ever watched the weather on the news, you'll hear the weatherman constantly talking about fronts coming in. Let's talk about what's actually happening at a front. A front is simply a boundary between two air masses. So let's do this. A boundary between two air masses. And an air mass is exactly what it sounds like. It's a big, giant chunk of air over the continent. There's all kinds of different air masses. Some of them form over the ocean, some form over land. The idea is that they all have kind of a general, this generally same temperature, humidity. The air is similar in an air mass. Now, if we have two blobs of air over the nation, maybe warm and dry here, and we've got one that is cold air here that's wet, maybe formed over like the ocean here in the north. We've got right in here, that region there is our front. Where those two air masses meet is a front. It's where there's a rapid change in air type, where a warm, dry air mass meets a cold, wet air mass, or where a warm, wet air mass meets a cold, dry air mass. That would be a great example of a front as well. Anytime two different types of air are meeting, we're going to form a front, a frontal system. And let's keep this real simple today. Let's look at a variety, the most basic set of fronts here, and we'll talk about the symbols used for each and what's actually going on. And we can get into some pretty good science of density and talk a little bit about what's causing weather here. So let's talk about a cold front first. We name a front after which air is winning. I always think about what type of air is winning in that push and pull between the air masses. When two air masses meet, inevitably, usually one is going to push the other out of the way. And every now and then they don't, and we call that a stationary front, and we'll talk about that a little later. But let's talk about a cold front first. In this case, the cold air mass runs into a warm air mass. And the cold air wedges under the warm air, forcing it upward. I'm going to draw this for you in a minute. And to think about, when I see a cold front on the map, if I look at a weather map on News Center and I see that there's a cold front moving towards Maine, I can quickly tell you what type of weather is usually coming, because cold fronts are known for severe weather and heavy precipitation. If we're getting thunderstorms, if we're getting, steady heavy rain coming through, usually that's due to a cold front that's moving through the area. So we associate that kind of more severe precipitation, heavy weather with cold fronts, and here's why. Let's think about what's happening here. If I draw the ground, I'm going to get all colorful here. Here's my ground. Okay, and now we've got our air mass. Let's draw it like this. I'm going to draw this wedge here, and I'm going to show that our cold air, we have cold back here. I'm going to draw with blue. We'll say cold air here is actually pushing warm air out of the way. So I'm using that arrow to show that the cold air is acting kind of like a wedge there and forcing that warm air out of the way. Now here's why it shapes up like that. It shapes up like that because Cold air is heavier, it's more dense than warm air, so it sinks lower to the ground generally, and because it's more dense, it wedges its way underneath that warm air, and as it wedges its way, you can imagine as this moves along, it kind of forces that warm air up that edge. And when we have warm air rising and cooling off, what we end up getting are all that moisture in the air that was down there near the ground. As it rises and cools off, we get condensation. We get warm air cooling off, forming clouds, and sure enough, we get lots of rain or snow or whatever coming from those clouds. So it's that classic example. I told you the answer to everything in this class is convection, and we're kind of forcing convection along here by getting that warm, moist air to rise. And that's what's going on in a cold front. Now, a cold front is drawn with a very specific symbol. It's drawn, that would be the edge between warm and cold air. And again, I'll draw it like this. If I'm looking down at a map, I know my cold air is here, my warm air is here. And if this is a cold front, then I'm going to use blue arrows that always point in the direction that the cold air is moving. So I know immediately when I look at a weather map, here's some things I can tell if I see that symbol on the map right there. I know that this air is colder than this air. Okay, and I know that because the direction the arrows are pointing, it tells me that cold air is moving this way. That's what that symbol tells me. So that immediately lets me know that that air mass is colder than that air mass. And that is the symbol used for a cold front. Let's look at the opposite here. Let's look at a warm front. So in a warm front, let's go back and we'll use black again for our font. In a warm front, warm air mass runs into a cold air mass. Now, warm air is less dense than cold air, so it doesn't hang as low to the ground. It wants to rise, and in fact, warm air has a tougher time moving cold air out of the way because of this. So we'll say warm air rides up the edge of cold air, and it moves more slowly usually. Cold fronts can move really quickly because of that kind of wedge shape that they form up there that can like wedge its way under the warm air and move a lot quicker. I'll draw that warm air front here in a minute. And then these guys are known for cloudiness and light precipitation. If we have just kind of a cloudy day with light precipitation, there's a decent chance we've got a warm front moving through. So let's draw, just like we did last time, let's think about what's going on in a warm front compared to a cold front. So here's the ground. I'm going to draw it in the exact same shape, but we're going to flip the arrow. We'll think about differences in direction here. So same exact shape, but now I've got warm air that's actually moving cold air out of the way. So now our warm air is winning. It's pushing that way, and it's moving that cold air out of the way. And let's draw blue here. We'll write cold. But again, if that warm air is pushing along, it can't wedge its way under the cold air because it's less dense, so it actually rides up that edge. And what happens is, again, we get that uplift. Oops, I'm going to draw that in black just like I did before. We get this kind of uplift that happens. And over in here, as that warm air rises, we actually get clouds that form. And the neat thing here is, check this out, okay? So there's your rain happening, right? There's your warm air rising up. But the neat part about this, and the thing I always find interesting is, let's say you're standing right here, okay? That's Tommy. Tommy's hanging out, he's trying to skateboard, and all of a sudden it starts raining because a warm front is coming through. Notice the air that he's actually standing in. It's still cold. So what happens a lot of times with a warm front is it rains, and then after the rain's done, after this air finally gets there, the rain has stopped and it feels warmer. So it actually rains down through the front and into the cold air mass. And that can cause snow and all kinds of stuff here in Maine. It could be warm way up above here, and dropping precipitation down to where it's cold and causing a snowstorm in the wintertime. That's a very common thing with a warm front here in Maine, which doesn't even seem right, right? You're like, what? Well, if a warm front's coming, it should be raining. But a lot of times what might happen is it might snow, and then the next day as this warm air catches up and moves in, you'll get that nice warm weather, or the very tail end of the activity might turn to rain. That kind of stuff happens around here all the time. So just an interesting difference there between a warm and cold air mass. Really, really neat stuff. So if we draw the symbol for a warm air mass, let's flip the script again. If we've got a cold air mass here, and we've got a warm air mass here, in a warm front now, I know that the warm air is winning if we draw it as a warm front, and a warm front is drawn with red half circles that show the direction that it's moving. So our red half circles are going to come in handy here, and I know immediately as I look at this symbol that A, it's a warm front because it's red, and B, that it's moving this way. Warm air is moving this way, and it is overtaking cold air, and I know that based upon the symbol. I know behind it must be the warm air, in front of it must be the cooler air. There's a lot of stuff I can tell just off that one little red line with half circles on a map. So just really cool stuff. There's the big difference. So the last thing that could happen here is an occluded front. This is a little more complicated. I'm going to go through it real quick. In an occluded front, let's see. What are we going to write here? We'll say that cold, a warm air mass is trapped between two colder air masses. And we see this a lot with like nor'easters. And because cold fronts move a lot quicker than warm fronts, here's what ends up happening sometimes. You might have, if we draw it over here, we might have a low pressure system, which we're going to talk about next time, rotates counterclockwise, and we may have a cold front coming off of that. Or I'm sorry, here's how this would look on the map. We're going to draw it in purple. An occluded front is drawn like this. Triangles and circles in purple. And we draw it like this. This tells us that it's kind of both a warm and cold front. And often they look like this on the map. And that's because we've got a cold air mass coming off like this. And we've got that warm air mass coming off like this. And what we've seen is that right in here, hang on, right in here, that cold air mass is actually caught up and started to overtake the warm air mass. And if we're going to draw it from a side view, we'd see the ground here. We'd see essentially that same wedge shape coming in. And now we've got something that looks a little bit like this. Cold, coldest, and that air is moving this way very rapidly. And then it takes that warm air and it actually wedges the whole warm air mass up into the air on both sides of that front. We've got uplift happening. And this is what we see often in our winter storms here in Maine. We get these big low pressure systems that come in just like this guy here, and we've got a warm and a cold front going along. Eventually that cold front catches up with the warm front and forms an occluded front, and we get all kinds of clouds up in here and warm air aloft, and we get that classic precipitation that happens. And remember, it's falling down through this colder air as it gets nearer to the ground, and boom, we end up with a big snowstorm in the winter, at least, when this kind of thing goes down. So just interesting weather symbols we're going to look for on the maps. This will be really helpful to you on your CK12 assignment and moving forward. Oh, and the last one I promised you we'd talk about was the Stationary front, you may run into that on CK12, I'm not sure. A stationary front would just kind of look like this. It would be a line, and on one side of that line we would have our blue triangles like this. On the other side of the line we would have our red circles like this. And if I quickly look at here, I look at that symbol, I know that the warm air is here and it's pushing this way, and I know that there is cold air here that must be pushing this way, and neither one is winning. We use that symbol to show that neither one is really winning the battle. They're both pushing against each other, but in some cases that front will just sit there, and we get stationary fronts that hang over Maine and cause all kinds of steady precipitation and cloudy weather for days at a time sometimes. So there's your stationary front. I might just label that stationary. And once you get good at looking at these symbols, you can tell a lot about what's going on, just telling the direction that the arrows are pointing. Again, I know the cold air's got to be here because those blue arrows are pointing the direction it wants to be moving. So the cold air's got to be behind that line. So yeah, good stuff. Helpful stuff, hopefully. Check out the other YouTube video I posted with this. The first 2 minutes or so are the best, where he really goes through what these symbols mean and how we throw them on the weather map. And we'll start watching a lot of News Center weather forecasts here in the future and start to apply our understanding of these symbols. It gets really exciting to watch the weather if you understand what the symbols on the map mean. So, as always, I'm here via email with any questions.